The Poiseuille's equation says resistance equals 8, the product of 8 viscosity, this n is viscosity, length divided by pi and radius raised to power 4. That is the value. Once you calculate that, you get the value of the resistance. So the question is, what is the use of that resistance? Knowing the total peripheral resistance or knowing the resistance of a tube will then allow you to plug that value into flow or pressure equations. So if we apply it, for example, to a flow equation, flow equals delta P or pressure gradient divided by resistance. What that means is, if for some reason the resistance increases, then the flow of blood would reduce in our body. For example, if we have arteriosclerosis or if we have sympathetic system that got triggered. So if the resistance increases, flow of blood would reduce. That would also mean nutritional needs will become a problem because nutrition would reduce. On the other hand, if resistance increases, that would reduce the flow. If resistance reduces, then the flow would increase. Now, do you want to keep increasing flow to the point that the blood is just going very fast? No, you also do not want. Too much flow would also cause a problem with the nutritional aspects, because the blood is passing so fast that the tissue cannot pick up the nutritional things. The fish is going so fast that you cannot fish it. So this is the utility of the resistance today. So let's look at it.